All right, so now we're going to move on to the so-called washer method. This method's called a washer method because if you take a look at the region that you're rotating, so here we are rotating about the x-axis. So let's, for instance, take a look here in this little diagram. We can take a look at our representative slice, highlighted in red here. So when this segment gets rotated about the x-axis, it will essentially be reflected down here, creating a mirror image. So if I draw that mirror image right about there, what happens is this point, what happens is this point here gets rotated down here, and vice versa, it goes back up here. Same thing here. This point here gets rotated down here and then gets rotated back up there. Let's make this one a little bit bigger. There we go. So this region that is that I'm going to shade in red, this is solid. But this region here in blue is empty. It is empty because if you think about the line segment, like if we were to draw all the way down from here to here, only this portion and this portion is part of the region. Everything in between here, there's not the shaded region. This shaded region only lives right here. So there's this gap between our axis of rotation and where our region, our area begins. So this gap, it also gets reproduced down here. So we get this sort of bored out hole in our region. And this is exactly what a washer looks like. A disk method is called a disk method because there is no gap, because our region that we're rotating about some axis actually touches our axis of rotation. So there is no gap, so this would just be completely filled in, which is a disk. So essentially what we're going to do for this kind of example here is we really want to just figure out the volume of this bigger disk, like we pretend it's actually full, and then we can find the volume of this region here as if it were a single disk. So a washer really is big disk minus little disk. That's exactly what we're going to do. Find the volume of the solid and then remove the volume of this solid that we're going to bore out. And our formula down here perfectly embodies that. We have the outer or the larger disk, so the radius of the outer or larger disk, minus the radius squared of the inner or the smaller disk. And if your disks are given by a function of x, then you can use that. But in general, I always prefer this kind of formula. It doesn't make reference to some function that may or may not be present. Okay. So this last little remark, if you read this, we are going to talk about shell method in the next section. So for now, we're not going to really read about this. We can come back to that in a little bit.